welcome to the geometry unit. In this lesson, we're going to look at the fundamentals of geometry. So we're going to talk about some of the basic vocabulary and concepts that you'll need to help you further understand what we're going to discuss. So what is geometry? Geometry means earth measure, but it's a branch of math that deals with shapes, angles, dimensions, and sizes of a variety of things that we see in our lives. Okay, let's talk about some of the definitions. We'll start out with the most basic definition, which is a point. And a point is just a location in space. Okay, and a picture of a point just looks like a dot. It's a closed circle. Might put a P there, label it with some other letter. And the symbol is, we really don't have a symbol. You can write either point P or you can just put a capital P, and that is recognized as a point. Okay, points don't have dimensions. An example of a point is if you were to pull out your phone and look at maps and look at your location, you would be a point on that map, right? So you are in a specific location. Points have zero size. Okay, now when we build on that and we form maybe like we have 2 points, we'll call it point A and point B, and then connect them. One of the things that we can form is a line. And what's special about a line is it has arrows which signify that it goes on forever in all directions, in both directions. So a line is formed by connecting 2 points along the shortest possible path. And the symbol for a line could be a little miniature version of a line. We can call this line AB. You can also reverse the letters and call it line BA. Okay, those both represent the same line since lines go on forever in both directions. It doesn't have a starting point or an ending point. Now, if we were to take that same line and only focus on the point A to point B inclusive, point A would be the starting point B is your end point, or vice versa, and all the points in between, we're dealing with a line segment. So a line segment is just a piece of a line. So we'll take A and B again, but this time we're not going to put arrows because we don't care about what is after B or before A. We only care about from A to B inclusive. So the symbol for that looks very similar to a line, except again, you're not going to have the arrows. You can also reverse it and call it line segment BA as well. And then we also have planes, and planes are just flat surfaces that extend forever in all directions. Okay, and there's no thickness to a plane. You may see planes represented as kind of like parallelograms, 4-sided figures with 2 pairs of parallel sides. But you can make a plane with less than 4 points. You can make a plane with 3 points, right? If you connect the 3 points, you end up with a triangle, and triangles are flat surfaces. that extend forever in all directions, theoretically. Okay, and the symbol, really, we don't have one. We would write the word plane, and you would call it plane WXY. You could call it XYW or YWX. The letter order does not matter. Something else I wanted to point out to you was the word ray, which a ray we'll kind of talk about when we get to angles, but I kind of wanted to mention it here. Rays have a beginning but no end. So if I was to add the word ray here, you would have a beginning point but no end point. So if I called this, let's say, ray WX, the symbol for it looks like this. Now, it's not correct to reverse it. You couldn't call this ray XW because W is what you call your initial point. That's where you start. And then X is called your terminal point because that's the direction where it goes on forever. So again, as with lines and line segments, you can reverse the letters because the order doesn't matter, but in an array, it does. Rays have a beginning, an initial point, but extend forever in one direction. Okay. So we're going to talk about dimensions, right? And when we say dimension, we're referring to dimension of an object. And what we mean is the number of independent directions in which you could move if you were on the object. So that's how I want you to think of dimension. So for example, we know our world is three-dimensional because you can move north, south, east, west, and up and down. So you can move in three different directions. Coordinates, or locations, is really what they are. You can think of dimension in terms of the number of coordinates required to locate a point. So here we have a coordinate, right? One coordinate locates a point on a line. Here you have two coordinates. You've got 2, 3, and they locate a point on a plane because you need an X and a Y. And then here, 3 coordinates. We call this an ordered triple. That's an ordered pair. 3 coordinates locate a point in space. So this is the X, Y, Z plane where you're able to draw 3-dimensional figures. So an angle, let's talk about those. One definition is it's 2 rays with a common endpoint. Okay, and that common endpoint has a name. It's called the vertex. You can also consider an angle as the intersection of 2 lines. Okay, or segments, which remember are just pieces of lines. Okay, and the vertex is the point of intersection or the common endpoint. One of the things to remember is how do we measure angles, and the most common way to measure angles are using degrees. There are other forms of measurement, so we can also measure angles in what are called radians, but we're going to focus on degrees. Okay, so if let's say I had a ray here, and I joined it with another ray here. You've got two rays. You've got your common endpoint, which we'll call A. And picture this angle inside of a circle where A is the center of the circle. Okay, as the rays move, it creates the angles. So let's pretend this was a 100-degree angle. Okay, we would say the measure of angle A, okay, so there's M stands for measure of, and then you've got the angle symbol, and A is equal to 100 degrees. So there's your degree symbol. We can classify angles in the following way. So we have what are called acute angles, which are angles between 0 degrees and 90 degrees. So a 90-degree angle, before I draw a picture, right, is a right angle. And right angles look like L's. So that's 90 degrees, and we signify that with a box. So a acute angle has to be smaller than that. So we're going to make this ray here, we're going to make it come in a little bit so that it's a smaller than an L. Okay, the opening isn't as wide. So maybe something like this could be an acute angle. Okay, so smaller than, my pen is not letting me make a straight line here. There we go. A smaller than 90 degrees, it's got a smaller opening, is an acute angle. Okay, so maybe this is like 45 degrees. And then we have obtuse angles, which are angles between 90 degrees and 180 degrees. Well, a 180-degree angle is a straight line. So straight angles are formed by straight lines. So here's your straight line, right? That would be like if you were looking at a clock and you had the minute hand pointing to the 12 and the hour hand was at the 6. It's forming a straight line. Or the minute hand was pointing to the 9 and the hour hand was pointing at the 3. That would be a straight angle. Okay, so an obtuse angle is between a right angle and a straight angle. So it's going to be bigger than 90 but less than 180. So maybe something like this. Okay, and maybe that's like 150 degrees. Okay, some more vocabulary that's important. We talk about complementary angles and supplementary angles. So anytime you have two angles that add up to 90 degrees, they're complementary. Okay, so let's pretend here's a 90-degree angle, which again looks like an L. There's my box, so that's how I know that it's 90. Maybe you have an an angle here that's 30 degrees, and the one right next door to it is 60 degrees. So this angle right here is 60, and the one next to it is 30. We would call those adjacent angles as well. Adjacent means next to. Adjacent angles are two angles that have a common vertex. They share a side. They're next to each other, but they don't share any common interior points. Okay, so those would be adjacent angles, but they're also complementary. Other complementary angles could be like 1 degree and 89 degrees because that adds up to 90. So as long as they add up to 90, they're complementary. Supplementary angles are angles whose sum is 180 degrees. So we know that what does a 180 degree angle look like? It looks like a straight line. Okay, but maybe you have an angle here that's like 60 degrees. If you're trying to find the angle that's supplementary to it, I would take 180 minus 60, and that leaves me with 120 degrees. Okay, other examples of supplementary angles could be like 1 degree and 179 degrees, or 20 degrees and 106. Oh, I used that one. And 20 degrees and 160 degrees. Those could be supplementary as long as they add up to 180 degrees. Two other lines that are very common in geometry are perpendicular lines and parallel lines. So what's the difference? Perpendicular lines are lines that intersect in a right angle. Okay, so maybe think of like, an intersection. So here's one street crossing the other street. Many times those streets will intersect at 90-degree angles. So that would be 90, this would be 90, this is 90, and this is 90. So they're all 90 degrees. And then you've got parallel lines, which are two lines in a plane that do not intersect. Okay, so think of like two sides of a street. As long as they're not intersecting, they are parallel to each other. So here we have two parallel lines. A lot of times in diagrams, they'll add an extra arrow onto the lines to show that they're parallel. Now I should also show you the labels for these. So let's say I said this was line L and this was line M. And I wanted to tell you like that they are perpendicular to each other. The symbol for perpendicular looks like an upside down T. So that's the symbol for perpendicular. That just says line L is perpendicular to line M. And then let's call this one maybe A and B. So if I want to say A is parallel to B, the symbol for parallel looks like two parallel lines. So that just says line A is parallel to line B. All right, now that we have a lot of background there, let's practice and apply some things. So here we want to find the degree measure of the angle that corresponds to a semicircle, which is half of a circle. Okay, so in other words, if I was to have a semicircle, how many degrees would that angle be that's formed in the circle? So again, picture the center of the circle as the vertex of the angle. Okay, so about here is my center, and let's say semi means half a circle, so I'm going to slice it in half. All right, and we know by looking at that that's how many degrees? It's a straight line, right? So straight lines, straight angles have 180, they measure 180 degrees. Well, how many degrees would an entire circle be if this was 180 degrees? Well, the semicircle underneath is also 180, right? So I know that that angle is 180 degrees, but a full circle has 180 plus 180, or 360 degrees. Okay, so remember that circles measure 360 degrees inside. So if I take half from the semicircle of 360 degrees, I end up with my 180 degrees. So that's the measure of the angle that corresponds to a semicircle. We know that quarter means 1/4, right? So I don't even need to draw the picture. I'm going to take 1/4 of the measure of an entire circle. So a whole circle is 360 degrees, and 1/4 of that is 360 divided by 4, which is 90 degrees. Okay, and that actually makes sense. So if I was to take this picture and just kind of duplicate it here to give you an idea. Okay, so there's my 180 degrees, right? That's broken in half. What if I break it into quarters now? Okay, well, let's think about this. I just divided the top part in 2 halves. Half of 180 is 90, right? So these are all 90. So that, again, shows you that the measure of the angle that corresponds to a quarter of a circle is 90 degrees, because 90 times 4 is 360, or 1/4 of 360 is 90. Okay, what I'd like you to do is pause the next two and try those on your own. And then we'll pick up with plane geometry. So when we say plane geometry, we're dealing with geometry on a plane. It's also referred to as Euclidean geometry. It's named after a Greek mathematician named Euclid. Okay, and it's the geometry of two-dimensional objects. One of those two-dimensional objects we're going to look at is a circle. So what is a circle? We just constructed one, but it's also a set of points equidistant from a fixed point and that fixed point is called the center of the circle. Okay, and the word equidistant, if you break it down, right, equi means equal, and then distant is distance. So it's just a circle is created when you have a fixed point, which is the center, and then you plot all the points the same distance from the center, and you get a circle. So for instance, like, here's my center, okay, and then if I was to create a circle around it, as you can see, every point that's on the circle, like this point here, is the same distance from the center as this point is here. So if I was to put a point and then put a bunch of other points the same distance away, you would end up with a circle. I mean, that's how tires are created, right? The tires on bicycles or on cars, you've got the center part, and that center is the same distance from all sides of that circle, okay, no matter where you are. Okay, so two other words that are going to be important for the lesson are the radius and the diameter. Those are both parts of the circle. How are they related? So if I was to take a line segment and draw it from one side of the circle to the other and it passes through the center, what you have here is what's called the diameter. So a diameter is just a segment that passes through both sides of the circle, so from one side to the other, through the center. It's the entire distance from one side of the circle to the other. Okay, and it's important that we say that it passes through the center because there are other segments that can go from one side of a circle to the opposite. Like I can draw another segment here, but that would not be the diameter. We call that a chord, C-H-O-R-D. Okay, so we're just going to focus on diameters. And then we also have a segment that goes from the center to one side of the circle. So this segment right here, and that segment is known as the radius. Okay, so the radius is the distance from the center to any part on the circle. Okay, and again, the radius is related to the diameter because it's half the diameter, and the diameter is 2 times the radius. Another two-dimensional object that we look at in plane geometry are polygons, and I'm sure you're very familiar with polygons. Polygons are just shapes. It's any closed shape in a plane that's made from straight line segments. Okay, you've seen lots of polygons before. Here's just a few of them. So we've got, a specific type of polygon is a regular polygon. So regular polygons are polygons where all the sides have the same length and all the interior angles are equal. Same length we call congruent. Congruent just means equal. You can have congruent line segments, you could have congruent sides, congruent angles. So a regular polygon is where they have congruent sides and all the angles are congruent. Okay, also called congruent. Okay, so you've got all of these here are regular polygons because all of their sides and all of their interior angles are equal. But here you've got a three-sided polygon, and we know that to be a triangle. And then underneath that you have a four-sided figure, but since it's regular and we know all the sides and angles are equal, that means it has to be a square. But generically, we would call a four-sided figure a quadrilateral. Okay, you've got a five-sided figure, which is a regular pentagon. And I should point out to you that this regular triangle is also called an equilateral triangle. So I'm going to squeeze that in here. Okay, equilateral, again, there's that word equi, that prefix equi, which means equal. Lateral comes from Latin, latus, which is sides. So this is an equilateral triangle. Again, we're calling it that because it's got all equal sides. Not all triangles have to have equal sides. We're going to talk about that. A six-sided figure that has all equal sides and all equal angles, we call that a regular hexagon. And then we have a regular octagon, which is 8 sides. Okay, stop signs are octagons. And then you've got a 10-sided figure, and this one is called a regular decagon. So triangles, we're going to look at them here really quick. They're worth mentioning. They're one of the most important polygons, and there's a few things that we need to discuss in order to look at some future problems when we're finding perimeters and circumferences and things like that, an area. So we know that an equilateral triangle has all equal sides, right? So that's one way to classify a triangle. So equilateral, it's got equal lengths. All three sides are equal. We also have triangles where at least two sides are equal. We call that isosceles. So they have at least two sides of equal length. And then we have scalene triangles. And scalene triangles have no equal sides. We not only can classify triangles by their sides, we can also classify them according to their angle measures. So we can have right triangles, we can have obtuse triangles, we can have acute triangles, which we've already kind of talked about all of those definitions before, so I won't write those down. Okay, so, a right triangle is where you have a triangle that has one right angle. An obtuse triangle is where you have a triangle that has an obtuse angle. And then acute triangles are triangles that have their three angles are less than 90 degrees. Okay, and you can name a triangle by its sides and angles. So it kind of has like a first and last name, kind of like people do. So you can have, you can have a right isosceles triangle. You can have an acute scalene triangle. So it just depends on the types of sides, whether they're equal and how many of them are equal, and then the angles. And that's the end of this video. In the next video, we're going to look at perimeter and circumference and areas and do some calculations, which I think will be very helpful. And then we'll also get into some three-dimensional geometry where we'll look at volume and surface area. Have a great day, everyone.